Let's start the class. So, but I need to check. Okay. We have learned about how to compute the center of mass, basically. How to compute the center of mass of a thin plate. We need to compute its mass, its moments about y-axis and x-axis, and then finally we can compute the centroid or center of mass. Sometimes we call it centroid, sometimes we call it center of mass. For this one, for this example, this is a little bit tricky. In this case, we only have a thin wire that we shape like wait, my camera is not on. Sorry for that. So we have a thin wire. So we have this wire, and then we shape it like a semicircle, like this. Well, it's exactly a semicircle, but let's just say that it is a perfect semicircle. And then we want to compute the centroid or center of mass of this wire. What we learned in the morning is, let's say we have a thin plate. A thin plate could be a paper, for example. The thin plate could be a paper. It's a plate like this. And what we we have computed how we have shown how to compute the center of mass of this thin plate. But now the problem is that in a thin plate we have area, basically. But in a wire, if we have a wire, we in the area below the wire, it's empty. So the way to compute the center of mass or the centroid is a little bit different. I will just show you this here, how to compute it. So basically a semicircle can be written as this equation. Say we have y equals square root of a squared minus x squared. In this case we have a semicircle with the radius a. Jadi di sini kita punya setengah lingkaran dengan jari-jari A. And in this case, the distribution of mass is symmetric about the y-axis. So since we have a circle like this, let's say we melipat itu fold. Okay, thank you. Let's say we fold the wire across the x-axis. So let's say we have this. Now we only have a quarter circle like this. So we see that the mass, the distribution of mass, is symmetric about the y-axis because here that on this side quarter and that quarter, they are the same. So basically, the center of mass coordinate for x is 0. X bar is 0. The problem is to find y bar. How to find y bar? Here, the mass first, which is dm, and the mass is actually delta times a times d theta. In this case, we have y tilde to be a sin theta. So the mass is now integral of dm, which is integral from 0 to pi, because we are considering semicircle. Semicircle is basically from 0 to pi. Setengah lingkaran itu sudutnya dari 0 sampai pi derajat. 0 sampai pi radian atau 0 sampai 180 derajat itu kita dapat setengah lingkaran ya. That's why the integral is from 0 to pi. And in this case, we have that the mass is delta times A times P. Then we, since we want to find the center of mass at the y coordinate, then we need to compute the moment about y-axis, which is basically this integral. We substitute y tilde with a sine x multiplied by dm, which is delta times a times d theta. In this case, we get that the moment about x-axis is 2 delta a squared. So in this case, we can finally compute the centroid coordinate that is given by 0, moment about x-axis over mass. Then we have 0,2a over pi. But we have to be careful here. I'm telling you that, say we have a semicircle, a thin plate with shaped semicircle. The centroid will be different. It's not this guy. Jadi kalau kita punya setengah lingkaran, tapi kita hanya punya apa namanya kulitnya saja ya, boundary yang paling atasnya saja, karena kabel kita bentuk setengah lingkaran gitu. Koordinat pusat masanya ini. Ya. Tapi kalau kita punya plate ya, atau kita punya plat tipis yang berbentuk setengah lingkaran, nanti koordinat untuk y-nya berbeda ya, agak sedikit berubah. This is well, I would say this is a special case for now. Yeah. Believe me that it is true. I want to continue with fluid force and centroids. Yeah, fluid force. So if we have a fluid, yeah, and well, let's say we have a pool, and then we have a flat vertical plate that we submerge. Pool fluid of weight density W. Then the force that acts on one side of the vertical plate is basically the product of W times distance h bar from the centroid to the fluid surface and the plate area. Gaya yang bekerja kalau kita punya kolam ya, yang isinya fluid atau cairan dengan rapat massa W, maka gaya yang bekerja dari air ke plat yang kita rendam ke dalam itu, yang kita taruh ke dalam, itu pada dasarnya adalah ini, F sama dengan W H bar kali A. So basically, okay, if we have a flat triangular plate with base 6 feet and height 3 feet submerged vertically. So let's draw the picture here. The picture here is actually something like this. A flat isosceles triangular plate with base 6 feet and height 3 feet is submerged vertically. Okay, so we have this flat plate. Yeah. The vertex, each vertex at the origin. So basically, we have this. And this is the coordinate. Is 0, 1, 2, 3. So here is -3. This is 1, 2, 3, 4, 5, 6. This is X, this is Y. And then, okay, the base is 6 feet. We have that the base here is 6 feet, and the height is 3 feet. And then, okay, merge vertically so that the base is 2 feet below the surface of a swimming pool. So now the surface is this area, these lines. This is the surface of swimming pool. So here we have that the distance here from the surface to the base of the triangle is 2 feet. Surface that the pool, okay, suppose that the pool surface is 5 feet from the bottom, and the weight density of fresh water is 62.4 pounds per feet. Then find the force exerted by the water against one side of a plate. Okay, if we have a triangle like this, then you can try to compute it later. The centroid is always third of the height. Yeah, the centroid is at this green. Sorry, let me use color, orange maybe, at this orange point. Yeah, this is centroid. So since we have that the centroid is there, then in that we have that the distance from the flat surface to the centroid is this distance, this purple distance. This is h bar, which is 3 feet. Okay, and then to compute the force, what we need is the weight, h bar, and area. Okay, the area of this triangle is basically of base and height of the triangle. So since we have that fresh waters, the weight density of fresh water is 62.4 pounds per feet cube, then the force is 62.4 times this h bar, which is 3 feet. This is h bar, and this 9 is area. Then we get that the force is around 1,684.8 pounds. Any question for this example?
Sir,
Ya.
kalau kayak koma-koma gitu, Sir, ntar boleh dibulatin nggak, Sir? Kalau kayak komanya banyak.
Okay, it depends on the questions, but normally you can round it up to two digits behind comma, up to 2 precision. So yeah, biasanya kalau tidak dituliskan, Anda bisa membulatkan sampai 2 angka di belakang koma. But if it is specified otherwise, for example, you are asked to write up to 8 precision. Misalkan Anda di soal diminta untuk menulis sampai 8 angka di belakang koma, ya ikuti soalnya. But normally there is no specific rules, then you can round it up to 2 precision. Yeah, clear?
Okay, clear, Sir. Thank you, Sir.
Okay. Now, the last part is the Pappus theorem for. So this Pappus theorem for volumes is basically saying that if a plane region is revolved once about a line in the plane that does not cut through the region's interior, then the volume of the solid it generates is equal to the region's area times the distance traveled by the region centroid to solution. So basically the volume is like this. Yeah. Okay. What Pappus theorem says is basically, okay, if you want to compute the volume of donuts, then basically a donut is a circle that you revolve around x-axis. Yeah. And then there is a distance between the center of the circle and the x-axis. If you revolve it, you will make a donut, and compute the volume is this way. Jadi apa sebenarnya teorema Pappus ini ya untuk volume? Kalau misalkan kita punya lingkaran, let me draw it here. This quite hard drawing, but okay. It's really hard to draw it by hand. So let's say we have this. Well, this is not a good circle anyway. And then we revolve the circle around x-axis. Then we will get some kind of donuts. So we will have something like this. Say we revolve it around the x-axis. Yeah. Then how to compute these donuts? We can use Pappus theorem. Yeah. So basically, it says that okay, we know that the center of the circle, this point, we know the center of mass, and we know that the distance to x-axis. This distance is rho, here, rho, and the area of the circle is area. Then the volume of the donuts is 2 pi times rho times the area. Yeah. Any question? Can you imagine this illustration?
Yes, I think so.
Ya, jadi kita punya donat. Pada dasarnya kalau kita potong, kita punya penampang bentuknya lingkaran. If we cut a donut, then we will have a side that shaped like a circle. Yeah. And then we revolve the circle so that we make a donut. Kita lingkaran ini ya, kita potong di mana-mana bentuknya tetap lingkaran. Jadi kalau kita putar, lama-lama dia akan berbentuk donat. Nah, to compute the volume, we use this Pappus theorem ya. Jadi untuk menghitung volumenya, maka kita menggunakan teorema ini. For example, okay, find the volume of the torus or donut generated by revolving a circular disk of radius a about an axis in its plane at a distance b greater or equal to a from its center. So we simply need to apply Pappus theorem with rho equals to b, and the area, since we have the radius is a, then the area is p a squared. Then the volume is basically this guy. Any question? No?
I think no, sir.
Now that was if we compute, if we want to compute, just compute the volume. Now, okay. Now how about if we want to compute only the surface area? Jadi kita hanya di sini hanya ingin menghitung luas permukaannya saja. Then the formula of the surface area is 2 pi p times L. 2 pi times rho times L. Rho is the same, yeah, but L now is just the arc. Jadi sekarang kita punya rho-nya tetap, tapi L-nya sekarang bukan luas, tapi kalau tadi kan kita untuk volume kita pakai luas ya, pakai A. L di sini ini hanya kelilingnya saja. So if we want to surface area of the torus in the previous example, we use the same rho, and the peripheral of the circle of the disk is 2 pi a. Jadi kita punya jarak antara titik pusat massa dari si disknya ke apa namanya, ke sumbu X itu adalah B. Kemudian kelilingnya adalah 2 pi kali jari-jari ya, keliling lingkaran. Then the surface area is basically this guy. It's quite clear, I think. Now some challenge. Find the center of a thin plate of constant density delta covering the region bounded by the parabola x squared and the line y equals to 4. So in this case, the center of mass. Okay, since we want to find what is the shape of the thin plate, then we need to the the intersection points, which is x must be equal to 4, then in this case we have x is plus 2. So the intersection point is 2 and minus 2. So let's say if we have this guy, this is the plot of this is x squared, and the blue lines is say here y equals to 4. Then the thin plate is basically this this part, this red shaded area, and we want to find the center of mass. Here, since the left side of the y-axis and the right side of the y-axis they are equal, then we know that x bar must be 0. So we just need to find the mass first, which is integral of let's check the formula again. The mass is integral of delta fx minus gx dx. Integral from minus 2 to 2 of delta times fx gx, fx minus gx. Fx is 4 minus gx is x squared dx, or this is actually equal to 2 times delta times integral from 0 to 2, 4 minus squared dx, which is equal to 2 delta 4x minus x cubed 3 from 0 to 2. Yeah. So we have that. Okay, if we put 2, then we have 8 minus 8 over 3, which is 16 over times 2. We have 32 delta over 3. This is the mass, and since we want to find what is y bar is equal to moment about x divided by the mass. So we have that moment about x-axis is, we just need to check, moment about x-axis is this guy. So integral from minus 2 to 2 delta over 2 4 squared minus x squared dx, this guy, and this is actually equal to delta over 2 integral from minus 2 to 2 16 minus x power 4 dx, and here you can check later by yourself that this is an even function. So the integral can becomes delta integral 0 to 2 16 minus x power dx, which is delta times 16x x power 5 over 5 0 to 2, which is 16 times 2 is 32, x times x power 5. 2 power 5 is also 32. 32 divided by 5. 32 multiplied by 5 is actually, okay, here we have 32 times 4, 8, 128 delta over 5. If you can check if my calculation is correct or not. Then we have that, okay. Then y bar is mx per m, which is 128 delta over 5 divided by 32 delta over 3. We can remove the delta, or okay, not, or we can write it like this: 128 delta over 5 multiplied by 3 over 32 delta. Yeah, we can cancel delta, and 128 divided by 32 is 4. So this is basically 12 over 5. So so we have that the centroid, or center of mass, is actually x bar comma y bar, which is 0, 12 over 5. Any question? Any question?
Sir,
Mm-hmm.
berarti ini kita pakai yang apa? Aturan yang MX itu ya? Ini berarti hasil dari yang MX itu ya, Sir?
Ya.
Yang MY-nya berarti yang nggak ada Y-nya gitu, Sir?
So here, x is my over m, y bar is mx over m.
Oh iya, betul.
So we interchange the variable name. Yeah. So that's why, okay, here, since we have that the plate is symmetric with respect to the y-axis, that's why x bar is here. Ya, karena plate-nya, karena platnya symmetric terhadap sumbu y, ya, maka pasti beban atau berat atau massa di sebelah kirinya sumbu y dan sebelah kanannya sumbu y itu sama. Makanya kenapa pusat massa untuk x-nya adalah 0. But what about the center of mass for y coordinates? Then we need to compute it this way. Yeah.
Okay,
take a look at the next. Find the center of mass of a thin plate of constant density. Here the density is also constant, covering the region cut from the first quadrant by the circle x squared plus y squared equals 9. So now we answer for A first. A, if we draw the plate, this is x, this is y, we have this circle on the first quadrant. Yeah, it's a quarter circle basically of radius 9. What we find is a center of mass somewhere here. Ya, jadi untuk yang A ini kita diminta mencari pusat massa untuk plat dipotong dari lingkaran ya, dengan jari-jari 9. X kuadrat tambah Y kuadrat sama dengan 9. Oh bukan jari-jari 9, ini jari-jari 3, sorry. Radius 3 dengan jari-jari 3. Lingkaran dengan jari-jari 3 tapi hanya kuadran pertama ya, berarti kita hanya ambil seperempat ini saja. Then in this case, first moment about the y-axis. Yeah, we return to this equation. Yeah. Moment about the y-axis, my is this formula. Y is integral from 0 to 3 x delta times x minus gx. So times fx is, in this case we have here y equals to square root of 9 minus x squared. So we have fx square root of 9 minus x squared minus gx. Gx is, because gx here is the x-axis, dx, and since delta constant, we can take out the delta. So this is equal to delta integral from 0 to 3 x square root of 9 minus x squared dx. For this problem, we try to integrate x square root of 9 minus x squared dx first. Yeah. So let's say here to u, then we have that du is minus 2x dx. So this integral now becomes minus integral of minus half of integral square root of u du, which is minus half integral minus half times 3 over 2, so 2 over 3 u power 3 over 2 plus c, which is minus 1/3 times 9 minus x squared power 3 over 2 plus c. So we can continue here. We have that now my is now integral, okay, delta times integral from 0 to 3 x square root of 9 minus x dx, which is equal to delta times minus 1/3 times minus x squared power 3 over 2 from 0 to 3, which is minus delta over 3, and then we substitute 9 minus 3 squared power 3 over 2 minus 9 minus 0 squared power 3 over 2. In this case, we have that here the score, the value is, okay, 9 minus 3 squared is 0. So we have this, this is 9. 9 power 3 over 2 is 3 power 3 is 27. So it is 27 delta over 3, which is 9 delta. And the moment about x-axis is integral from 0 to 3 delta over 2 times delta over 2 times square root of 9 minus x squared minus 0 dx, which is equal to delta over 2 integral from 0 to 3 9 minus x squared dx, which is equal to delta over 2 times 9x minus x cubed over 3 from 0 to 3. Here we have delta over 2 times 9 times 3 is 27 minus okay, 3 cubed is 27 divided by 3 is 9. Yeah, 27 minus 9 is 18. So here we have that moment about x-axis is also 9 delta, and the mass is integral from 0 to 3, this guy, delta square root of 9 minus x squared minus 0 dx, yeah, which is delta times integral from 0 to 3 integral from 0 to 3 square root of 9 minus x squared dx. It's a little bit harder. Now we let u to be equals to 3, not u. Let x equal 3 cosine theta, which means that the dx is actually minus 3 sine theta d theta. So integral of square root of 9 minus x squared dx is equal to integral of square root of 9 minus 9 cosine squared theta dx is now becoming minus 3 sine theta d theta. So this is equal to integral of square root of 9 times 1 minus cosine squared theta times minus 3 sine theta d theta, which is equal to integral 3 sine theta, because 1 minus cosine squared theta is basically sine squared theta. 3 sine theta, 3 sine theta d theta, which is integral of minus integral of 9 sine squared theta d theta. And then we use the fact that sine squared theta is equal to so cosine of 2 theta is equal to cosine squared theta minus sine squared theta, which is 1 minus 2 sine squared theta. Then in this case we have sine squared theta is half of minus cosine 2 theta. So integral now becomes minus 9 over 2 integral of 1 minus cosine 2 theta d theta, which is minus 9 over 2 times theta minus sine 2 theta over 2 plus constant. So the mass is now delta times integral from 0 to 3 square root of 9 minus x squared dx, which is here we have that theta is arc cos of x over So here we have delta times 9 over 2 times theta is arc cosine inverse of x over 3 minus sine of 2 times cosine inverse of x over 3 divided by 2. And we put from 0 to 3. Yeah. So basically this is minus 9 delta over 2 times, this is the hard part, cosine inverse of 3 over 3 minus sine of 2 cosine inverse uh, 3 over 3 divided by 2. minus cos inverse 0 minus sine of 2 cosine inverse 0 divided by 2. Here we have minus 9 delta over 2 multiplied by cosine inverse of 1 is 0. 0 minus sine 2 times cosine inverse of 1 is basically pi over 2. So 2 times pi over 2 divided by 2 minus cosine of 0 is pi over 2 minus sine cosine inverse of 1 is 0. Sorry, I made a mistake here. Cosine inverse of 1 is 0, so it should be 2 times 0. 2 times 0. So, but now here we have sine of 2 times pi over 2 divided by 2. Sine 0 is 0, so this guy is 0. Sine pi is also 0, so this is 0. So now mass is basically 9 pi delta over 4. So finally, we can compute the center of mass. X bar is mx divided by m. My divided by m is 9 delta. 9 delta divided by 9 pi delta over 4, or this is equal to 9 delta multiplied by 4 over 9 pi delta. So we can cancel the 9 delta. So we have x bar is 4 over pi, and y bar is also okay, since mx divided by m is 9 delta divided by 9 pi delta over 4, which is also 4 over pi. Yeah. The question? Feel the pressure now?
Sir, the X bar and Y bar must be the same, right? Harus sama gitu, Pak Purvi.
Enggak.
It can be different.
It can be different. Yeah, it can be different. For example, this one. Yeah, X bar is 0, Y bar is 12 over 5. In this case, somehow we get that X bar and Y bar. Yeah. Why? Because the moments are the same. The moments are 9 delta. Nah, jadi pada dasarnya titik pusat massa itu X bar dan Y barnya tidak selalu sama ya. Nah, di kebanyakan kasus di contoh ini kebetulan momen dari momen terhadap X aksisnya dan Y aksisnya kebetulan sama-sama 9 delta. Sehingga kita dapat X bar dan Y barnya sama. Ya.
Yes, sir. And there is no short equation, right?
There is no
short equation, or
no.
maybe there is. Okay. Well, it's quite long.
Now you are an undergraduate student ya. Kalian itu mahasiswa. No more shortcuts.
Yeah, sir.
Yeah.
Can I write this?
Any other question?
Nah. Okay, thank you, sir. The Y bar.
question? No?
Yes, sir. I already finished the right thing.
For the B, you can try by yourself, okay? Untuk latihan yang B, kalian bisa coba sendiri di rumah. I already did the hard work, so you don't need to again. Now this one. What if now the density is constant? Here the density is x. In this case, we have to, okay, again compute m x my x first way. Let's try to compute my first. The moment about yx, my is equal to integral from 1 to 2, yeah, from this yellow, from this green part, integral 1 to 2 of x times delta times fx minus gx dx, which is integral from 1 to 2 x multiplied by x squared. X squared is the delta. This is delta. Multiplied by f of x minus g of x. Yeah, g of x is 0. So multiplied by 2 over x squared. 2 over x squared minus 0 dx, which is integral to 2. In this case, we have 2 dx, which is x squared from 1 to 2. We have 4 minus 1 is 3. And then the moment about x-axis, integral from 1 to 2 delta over 2 f squared minus e squared dx. We have integral from 1 to 2 delta is x squared. X squared times 2 over squared minus 0 squared dx, which is the integral. So this should be over 2. Integral from 1 to 2 of 2 over x squared dx, or integral from 1 to 2 to x power minus 2 dx, which 2 times minus 1 over x from 1 to 2. Here we have 2 times minus 1 over 2, 1 over 1, which is 1. And finally, we compute the mass, which is integral from 1 to 2 delta times fx minus gx dx. We have here integral from 1 to 2 x squared times 2 over x squared dx, which is integral from 1 to 2 of 2 dx. Here we have 2x from 1 to 2, which is 2. Finally, we can compute the centroid. Finally, we can compute the centroid. X bar is my over m, which is 3 over 2, and y bar mx over m, which is 1 over 2. The question? Is it clear?
Yes, sir, it's clear.
This one you can try to do it at home. Idea is just try to compute the moments about y-axis and then moments about x-axis and then the mass. Finally, compute the centroid coordinates. Those are the steps that you need to take. Now I want to talk about the next material, which is about volume using cross sections. So if we want to compute the volume of a solid of integrable sectional area A from A to B, basically the integral of A from A to B. Yeah. So if we have, okay, let's say we have a cylinder. We want to compute the volume of the cylinder. We have the base A is a circle, and we know that the area is the circle. And then we want to compute the volume. Basically, we take the circle, we move it from bottom to up, and then the whole area covered by the movement is basically the volume. So in the cylinder case, it's basically base area multiplied by the height, and in general, if the shape is a little bit different, then in general the volume is like this. Yeah, because somehow there might be dent on the side of the can or a cylinder. Ya. Jadi misalkan kita punya silinder tabung gitu ya. Kalau bentuknya ideal, maka dia lingkaran, benar-benar lingkaran dari bawah ke atas gitu ya. Tidak ada lengkukan apa-apa. Tapi misalkan kita punya kaleng berbentuk tabung gitu ya. Kaleng ini dia biasanya kalau contoh kaleng sarden, gitu. Kaleng sarden itu dia biasanya ada lekukannya. Nah, lekukan ini membuat volume di dalamnya itu menjadi berubah. Kalau bentuknya dia lurus saja, tingginya ke atas itu lurus saja, maka volumenya tinggal luas alas kali tinggi. Tapi kalau ada lekukannya, kita harus menggunakan rumus ini, integral. And these are the steps. Basically, there are 4 steps to calculating the volume of the solid. If possible, try as best to sketch the solid. For example, yeah, if to compute the volume of this pyramid, the height of the pyramid is 3 meters. let's say we put this the height on the x-axis. Ya. Di sini kita taruh tingginya ada di sumbu x, and it has a square base that is 3 meters on a side. Jadi kita punya area, ya, base-nya yang apa namanya, yang panjang sisinya adalah 3 meter. Then, okay, we have that, okay, if we cut the cross section, ya, jadi kalau kita potong yang sejajar dengan apa namanya, dasar dari piramidnya, kita potong persegi, ya, that the sides are x, ya. At point x, ya, if we cut it at point x, we have a cross section that's shaped like a square with sides x. Jadi kalau di sini contohnya kita potong di titik x, maka piramid ini akan di titik itu berbentuk segi 4 dengan panjang sisinya adalah x. Then in this case we have that the formula for the area is ax equal to x squared. Then what is the volume the pyramid? It's basically the integral from 0 to 3 of the area, which is x squared, integral from 0 to 3 of x squared dx, which is 9 meters cubed. Any question? Any question?
Sir.
Ya.
Supaya jadi 9 meter persegi itu berarti kan dari x per 3-nya itu kita
Masukkan
jadi 3
dikurangi
masukkan 3.
Oh. Ya.
Nah, oke.
Yeah. So the steps are, first try to sketch the graph, the thing that you want to compute, and then and after that try the cross sectional area, ya. Digambar dulu piramidnya, kemudian cari kalau kita potong di sumbu y, ya. Jadi kita potong di x berapapun yang sejajar dengan alasnya ini. Jadi kita potong pakai vertikal gitu ya. Setelah kita potong, ternyata kita dapat bahwa luasnya adalah ini, luas dari persegi dengan sisinya x. Baru kita masuk rumus volumenya. Ya. Question for this? No?
I think no, sir.
Now, volume by disk rotation about x-axis. Now, we want to compute the volume, but basically we rotate the curve by about the x-axis. Yeah, basically the volume remains the same. V is equal to square root of ax dx. But now the area, since we use the rotation about x-axis, the area becomes pi times r squared. Di sini kita mau mencari volume dari kurva yang kita putar pada sumbu x. Maka ketika kita potong, ya, maka areanya karena kita putar pada sumbu x, bentukan bentukan potongannya pasti lingkaran. Makanya kita pakai areanya adalah rumus lingkaran, yaitu pi jari-jari kuadrat. Jari-jarinya apa? Jari-jarinya adalah fungsinya. Fungsi yang mau kita putar itu. if we want to compute the region between the curve y equals to x, square root of x, yeah, this blue curve in the picture, from 0 to 4, and we revolve the about x-axis, ya. Jadi kita putar pada sumbu x, then we will generate this kind of solids, ya, that looks like peluru itu apa ya? Peluru. Yeah, that looks like a bullet or projectile. So now we have a bullet. Yeah. We can actually generate a bullet using in this way. Yeah, we draw the curve. We rotate the curve of y equals to square root of x across, about the x-axis, and then we will have a bullet, and we are asked to find the volume of this bullet. So the volume is basically from 0 to 4, pi times the radius. The radius here is the curve y equals to square root of x. So the radius is square root of x. We take it, we square the radius, dx. The volume of this guy is 8 pi. For this example, any question? Any question? Is it clear enough, or?
For me, it's clear, sir.
In Bahasa, usually this method is called method cakram. Yeah. Cakram means disk. Yeah. Basically, because we have disk here. Next example. Okay. Find the volume of the solid generated by revolving the region bounded by y equals to square root of x and the lines y equals to 1, x equals to 4 about line x equals to y equals to 1. This one, I believe I need to show you the illustration. So here what we have is, okay, say this is y equals square root of x, and then we have the lines x equal to 4. Okay, this is x, yeah, this is y, x equals to 4 here, x equal to 4, and we have the lines y equals to 1. Y equals to 1, and we revolve about the line y equals to 1. Jadi this guy. So this is the revolution. So now the radius becomes only this guy. The red one is the radius, r of x. So here we have that r of x, the radius is basically square root of x minus 1. because we want to revolve it about y, the lines y equals to 1. And here we find that this point, sorry, let me use the orange. This point, orange point, this is actually y equals to 1 equals to square root of x. So here we have that x equal to 1. So the integration becomes like this. So the volume is integral from 1 to 4 pi rx squared, which is integral from 1 to 4 pi times square root of x minus 1 squared dx. And then basically we just need to follow the rest of the process. And, we have this, and then basically we find that the volume is 7 pi over 6. For this example, is it clear or any question? Any question? No?
I think it's no, sir.
Sir,
Ya?
itu yang sama dengan yang kedua dari bawah itu yang paling terakhir dapat x kuadrat per 2 min 2 kali 2 per 3 x pangkat 3 per 2 dan seterusnya itu dari mana, Sir?
Integral of x minus 2 square root of x plus 1 with respect to x is this inside the bracket. Ya, integral dari x minus 2 akar x plus 1 terhadap x itu adalah ini, x kuadrat per 2 min 2 kali 2 per 3 maka 3 per 2 plus x.
Oke, Sir, paham. Terima kasih, Sir.
Ya. Other question? No? Now, what if we want to rotate it about y-axis? Well, the formula is the same. Yeah. So, find the volume generated by the solid. Find the volume of the solid generated by revolving the region between the y-axis and the curve y equals to 2 over y from 1 to 4 about the y-axis. So we have that here the radius is 2 over y. This is the radius, and since it is between the y-axis and the curve x equal to 2 over y, we rotate it about the y-axis, then we have that the radius is 2 over y, then we simply need to finish the integration. Yeah, we just need to use this formula. Any question? If you're not sure about what I'm doing here, try to draw this curve x equal to 2 over y from 1 to 4. Kalau Anda tidak yakin yang saya kerjakan di sini benar, coba gambar kurvanya, kemudian kemudian dilihat apakah radiusnya benar-benar ini. This is how we compute it, yeah. And then, okay, now this is a little bit different. For this one, I want to also give you the illustration. for this one, we draw x equal to y squared plus 1. So we draw it like this. This is x equal to y squared plus 1. This is, we have x-axis, and the vertical axis is y-axis. And we also have the region between the parabola and the line x equal 3. X equal 3 is this line. This is 1. This is x equal 3. Yeah. So in this case, the region is this region. But now what we want to do is we revolve it about this line. Yeah. We revolve about the line x equal to 3. So first thing that we do is to find these two intersection points by making y squared plus 1 equal to 3. So in this case, we have that y squared equal to 2. That's why y equals to plus minus square root of 2. So this is basically square root of 2, and the bottom one is minus square root of 2. Since we want to revolve it around x equal to 3, then the radius, we use the green one, the radius is this. This is the radius y, which is equal to 3 minus y squared plus 1, which is equal to 2 minus y squared. This is the radius. So finally, we do this step. We compute the volume, the limit integration between minus square root of 2 to root of 2, and we have the integrand is pi times the radius squared. The radius is 2 minus y squared dy. So here that this is equal to integral minus square root of 2 to square root of 2 pi times 4 minus 4y squared plus y power 4 dy. That's why we have this integration. This is results of the integral. So the volume is 64 pi square root of 2 divided by 15. Any question? Any question? No? Ya, jadi di sini kita diminta untuk mencari volume dari benda padat yang dibuat dengan memutarkan area yang saya apa namanya, arsir merah, ya. Pada sumbu X sama dengan 3. Pada garis X sama dengan 3, maka kita dapat ternyata volumenya adalah ini. Ya. And what if we have this kind of solid? Yeah, we have a washers. Sebelumnya kita menghitung volume, ya, kita punya cakram ini, disk cakram. Tapi sekarang kita punya bukan cakram tapi cincin. Ini washer itu sebenarnya cincin, ya. Jadi ilustrasinya nggak ada. The volume basically the same, just that we take the area, the bigger area minus the smaller area. So, for example, this guy, let me give you the illustration. The region bounded by the curve y equals to x squared plus 1 and the line y equals to minus x plus 3, then let me just draw it here. The first one is x squared plus 1. 1, and the second one is the line minus x plus 3. And we draw, let's say, from minus 3 up to 2. Now let's just take this plot. Okay. So here we have that the red one is the lines y equals to minus x plus 3. And the blue curve is the curve y equals to x squared plus 1. Now this is x-axis, and y-axis, and what we find is okay, we want to compute the volume of the solid generated by revolving this green shaded area. We want to revolve it about the x. Yeah, so basically we want to revolve it like this. So in this case, if we revolve it, we will get something like this. Is too big, but it's okay. And somewhere in the middle we have small holes. So it looks like a donut again. So in this case, what we need to do is we find actually the radius of the area. This, let me use different color. The radius is basically this guy. So this is the yellow lines. It's basically okay. If we want to compute this area, if we want to compute this area A, yeah, this area is actually pi times r squared. Okay. This orange is basically this donuts, but only a plate, ya, only some kind of ring. Kita punya cincin saja, ya. Jadi area donatnya, area ringnya, ya, ini adalah lingkaran besar, ya, pi r squared minus pi small squared. This is the bigger circle, and this is the small circle. So here we have that area is pi times r squared minus small r. That's why we get this formula. So here that the big R is this guy, yeah. This is big R, and the bottom one is the small. So that's why we have the volume becomes integral from -2 to 1, because the integration is from this intersection to that intersection. From -2 to 1, pi times minus x plus 3 squared, because the top radius is minus x plus 3, minus x squared plus 1 squared, because the bottom radius is x squared plus 1. So if we expand this square, then we get that the integral now becomes integral from -2 to 1, pi times 8 minus 6x minus x squared minus cube, minus x power 4 dx, which in the end we get that the volume is 117 pi over 5. For this example, any question? Any question?
Sir, I'm sorry, but the 8 before the minus 6x from where ya? Dari mana ya?
This one?
The 8. The 8, yeah.
8 minus, okay. The 8 comes from here. 3 squared is 9 minus 1 squared is 1, so 9 minus 1 is 8. Just try to explain.
After that, we expand it, right?
Yes. We have that minus x plus 3 squared is x squared minus 9x plus x plus 9, and x squared minus 1 is x squared plus 1 squared is x power 4 plus 2x squared plus 1. Like, if we subtract them, then we get 8 minus 6x minus x squared minus x power 4. Yeah, is it clear now?
Yeah, it's clear, sir.
Okay, any other question? No? Then let's go to the next example. Yeah. Here we, in this case, we revolve the area about the y-axis. Now the formula becomes like this. Basically, we just need to change x into y. And we know that from 0 to 4, square root of y is always greater than y over 2. So we have this equation for the volume. Then finally we get that the volume is 8 pi over 3. Yeah. Try to draw the picture for these two parabola. And remember that here, since we want to revolve about the y-axis, so somehow we need to change everything into x as a function of y. Here we have that x equal to square root of y. This line is x equal to y over 2. That's why here we have square root of y, and here we have y over 2. Yeah. Let's just tackle some these three challenge, and let's end this course. The solid lies between planes perpendicular to x-axis at x0 and x equal to 4. Jadi ini tegak lurus ya artinya. The cross-section perpendicular to x-axis on the interval 0 to 4 are squares whose diagonals run from the parabola y equals to square root minus square root of x to parabola y equals to square root of x. So if we draw it, this is x, this is y, and we have the parabola. The top one here is y equals to square root of x, and the bottom one is y equals to minus square root of x. And we have that solid. The base is square whose diagonal run from the parabola. Okay, So basically what is something like this. Not like this. Something like this. Don't know if this is visible, but okay, anyway. And we have that the diagonal is here. Yeah, this is the diagonal. So if we take diagonal, if we take a square, and this is the diagonal runs from minus x square root of x to square root of x. Then the diagonal is basically 2 times square root of x. And what are the sides? So let's say here is a and a. We have that a squared plus a squared, since we are talking about this kind of triangle. It must be equal to 2 square root of x squared. So here we have 2a equals to 4x, a squared equals to 2x, so a equals to square root of 2. So in this case, we have that the area is since the area is small a squared, yeah, which is square root of 2x squared, which is 2x, then the volume is the integral from 0 to 4 2 dx, which is x squared from 0 to 4, which is 4 squared is 16. Any question for this example? Ya. Jadi di sini ceritanya apa namanya? Kursornya. Ceritanya kita punya apa namanya? Benda padat ya, yang diletakkan tegak lurus terhadap sumbu x, di mana kalau kita potong ya, kalau kita potong base-nya itu cross sectional area-nya adalah bentuknya square ya, atau persegi. Persegi yang diagonalnya itu parabola minus akar x sampai akar x. Maka kalau kita ambil persegi ya, dari minus akar x sampai akar x itu kan berarti panjang 2 kali akar x ya. Maka diagonalnya adalah 2 kali akar x. Maka dari situ kita bisa cari sisinya berapa. Ternyata sisinya adalah akar 2x. Dari sini kita bisa tahu bahwa apa namanya volume luasnya adalah sisi kuadrat ya, karena persegi. Maka luasnya adalah 2x, sehingga volumenya adalah ini 16. Ada pertanyaan? Any question? No.
No, sir.
Is it clear or confused? I hope that it is clear. You know that hope is always a dangerous thing. Yeah.
Jay, you want to ask first?
No.
Well, sir, what if the x? Bagaimana kalau x-nya itu udah diketahui duluan?
What do you mean? The side is known.
Oh, itu pasti nggak bisa diketahui duluan ya?
No, in this case, no.
Oke,
It always depends on the problem. Yeah. Don't be afraid of story kind of questions. Ya. Jadi jangan pernah takut dengan soal cerita. Ya. Especially since you are chemical engineering, you will face a lot of you will find this kind of questions a lot. Terutama karena kalian mahasiswa teknik akan menemukan soal-soal seperti ini cukup sering. Okay. Now let's work on this second problem. Find the volume of the solid generated by this revolving the shaded region about the given axis. Here, about the x-axis. So the volume is simply integral from 0 to 2, 0 to 2, pi times r squared. Here we have that r of x, which is equal to y, which this is equal to 1 minus x over 2. So 1 minus x over 2 squared dx. This is now integral from 0 to 2 pi times 1 minus x plus x squared over 4 dx. The integral is pi times x minus x squared over 2 plus x cubed over 12 from 0 to 2. So here we have the volume is, if I put 2 here, 2 minus 2, 0. So here 2 power 3, 8 over 12 over 12 pi, or if we divide by 4, we have 2 over 3 pi. This is for this problem, and the next problem is find the volume of solid generated by revolving the shaded region about the indicated axis. Here again we revolve it about the x-axis. We revolve again about the x-axis. Then in this case we have that the volume is integral from minus pi over 2 to pi over 2 of pi times 1 squared minus cosine, minus square root of cosine of x squared dx, which is integral from minus pi over 2 to pi over 2 of pi times 1 minus cosine of x dx. And here we have that this function is even, but it doesn't matter. Let's just integrate it. We have the integral becomes pi x minus sine of x from minus pi over 2 to pi over 2 is pi times pi over 2 minus sine of pi over 2 minus pi over 2 minus pi over 2 minus sine of minus pi over 2 sine pi over 2, we have that sine pi over 2 is equal to 1, and sine minus pi over 2 is equal to minus 1. So this is now equals to pi times pi over 2 minus 1 plus pi over 2 minus 1. So we have pi times pi minus 2, which is pi squared minus 2 pi. So for the last two questions, any questions? Any question? No? If not, end this session. Okay, let's just end this session and give you some time to ask question after I finish this session. Yeah. So those who want to leave, you can leave. Those who want to stay, you can stay. I will only give you about 20 minutes. Yeah. Let me end this session. See you on Monday, yeah, on the midterm exam. See you face to face. Let me end this session. Good afternoon. Assalamualaikum warahmatullahi wabarakatuh, and happy weekend.
Thank you, sir. See you.
Thank you.